In this video, we're going to look at another example of looking at the area of a region between two curves. We're just going to have to do this one as two integrals because our bounding functions will change as we go across our interval. So what do I mean by that? Well, let's look at the problem here. We're doing the area between the curves y equals cosine x and y equals 1 minus cosine x from 0 to pi. So this curve will be our y equals cosine x curve. And this curve is our y equals 1 minus cosine x curve. Notice that on this first part of this interval, from 0 to a little bit bigger than 1, notice that the cosine x curve is above the 1 minus cosine x curve. So for that integral, we want to do top minus bottom, we would have cosine x minus 1 minus cosine x. However, from that point on to pi, now 1 minus cosine x is above the cosine curve. So we would do 1 minus cosine x minus the cosine x. So we're going to have to split this up into two integrals. All right, so first let's figure out where we need to split. Let's set our cosine equal to the 1 minus cosine. Rearrange that equation. We get to cosine x equals a half. We're looking in the interval from 0 to pi. The x value where cosine is equal to a half in between 0 and pi is pi over 3. So this will be where we split. All right, so we can actually define our area here as the integral from 0 to pi of the absolute value of the difference of the two functions, because absolute value will always make it positive, and of course our area here should always be positive. But we've already analyzed this to talk about how we need to split this. We're going to split it at pi over 3, so that's why we have the two integrals, split at pi over 3. We said that cosine was above 1 minus cosine from 0 to pi over 3, so we'll do cosine minus 1 minus cosine. Notice that makes this positive, so your absolute value wouldn't do anything. From pi over 3 to pi, the 1 minus cosine of x is above the cosine x, so we'll do 1 minus cosine minus cosine. And again here, if we look at in terms of the absolute value, if this one, cosine x, were below 1 minus cosine x, then this would be negative, so the absolute value is going to make it positive, or basically reverse the order here. All right, do a little housekeeping here with simplifying our integrands before we take the antiderivative. Antiderivative for 2 cosine x is 2 sine x, and antiderivative for 1 is just x, and we get the same pieces there. Plugging in our endpoints now, again, put in your upper limit of integration, subtract off what you get when you put in your lower limit of integration. We're using fundamental theorem of calculus here for both of the integrals, and then do some simplifying, and you should get pi over 3 plus 2 root 3.